This is day 2, page 8. We've been given a graph. It says it's a function R of A, and it tells us that A is the dollars that they're spending on advertising per day in a certain market. So we're inputting A dollars spent on ads, and it says it's outputting the revenue R of A in dollars. All right, first it's just asking, is this function increasing or decreasing? And to interpret the meaning, I see that as we travel from left to right, the graph goes up, so the graph is increasing. And in real world terms, it's saying as the advertising dollars spent increases, the revenue increases. So I could just say that in kind of simple terms. As they spend more and more on advertising, they make more and more on revenue. Estimate the inflection point. Again, an inflection point is a point where the graph changes its concavity. So in this case, it looks like the graph is concave up, and it changes approximately here to concave down. So again, this is just an estimate. So for mine, I estimate this inflection point happens at about an input of 40. And let's see, I'm going to guesstimate that that output's about 140,000. It's just an estimate. Yours might be slightly different. So I'm estimating 40, 140,000. We want to interpret the meaning of that point in context. So this graph is increasing throughout this entire domain, but we see as we travel from left to right, starting at 0, the graph is very, very flat here. It's only increasing at a very slow rate. Then it's getting steeper and steeper. So it's increasing at a faster and faster rate right up until here, the inflection point. Then after that inflection point, it's getting less steep and less steep until at the end of the domain here, it looks very flat again. In fact, it gets steeper, steeper, steeper right up until this inflection point. And that inflection point is the point where it is steepest. All right, so the inflection point in this graph is the point where it's steepest. What would that mean in real world terms? Right at this point, at the inflection point, when they are spending $40 a day on advertising, if they were to increase to spending $41 per day, they would have a great big increase in their revenue. Notice over here at, for example, $90 in advertising spent, if they increase from $90 to $91, they only go up in revenue a teeny tiny amount. And over here, if they went from $0 in advertising up to $1 in advertising, they only increase a teeny tiny amount in revenue. But right here, this is the greatest amount of revenue increase, going from $40 to $41. So that is where their revenue is increasing at the highest rate. They get the most return from increasing their advertising expenditure, right there at an expenditure of $40 per day on advertising. So again, when spending $40 a day on advertising, the revenue is increasing fastest. Increasing advertising expenses by $1 at that time will have a big effect on revenue. Identify where the function's concave up. We'll write it in interval notation and interpret. Concave up. So again, let me put that in red. Concave up, like the bowl is right side up. That's over here to the left of the inflection point. Concave up. Looks like it's happening from 0 up to our inflection point at 40. So the interval where the function is concave up is 0 to 40. And this is telling us that when they increase from $0 to $40 in advertising expenses, revenue is increasing at a faster and faster pace. Part D asks to identify where the function's concave down and interpret. So the concave down happens after the inflection point, so after $40 in expenses. So you might write that as advertising greater than $40 per day, or you might actually stop it here at the end of the given domain in the pictures at about 100. So I think either would be acceptable. You could say $40 up to infinity, because technically they could probably spend up to infinity dollars, keep spending and spending on advertising. Or maybe you would just stop that at the end of the given picture at $100 spent. Either one of those would be fine. So on that interval, the more and more they spend on advertising, the more and more revenue they make. However, as they increase advertising dollars, the impact on revenue is getting smaller and smaller. Identify the right tail behavior. All right, the right tail behavior. On the right side of the function, we see that this function is approaching a height of, I don't know, it's going above 300,000. So let's say maybe 350,000. Again, it's an estimate. So it says right in interval notation, that's a typo. So we'd say on the right tail, the R of A value is approaching 350,000. It's saying as the advertising dollars spent get higher and higher and higher, the revenue is approaching $350,000. It seems to be flattening out. Doesn't seem to be that it would just keep shooting up to higher and higher revenues. They're pouring money into advertising, but it's not really having any effect on the revenue any longer. So if it just keeps flattening out, there would be no reason to spend more and more on advertising since it's not affecting the revenue in any meaningful way. So spending more and more on advertising is just making the revenue approach $350,000 still.